In this video, we're going to take a look at example number 1. Let's see what it says. I want to test for a negative linear relationship between the weight and highway fuel efficiency of these different cars that we have listed here. And I'm going to use a 0.01 level of significance. We'll assume the data was collected through a random sample. Okay, now it's really important again to kind of lay the groundwork right away for what it is that we're trying to work with. So I'm going to switch over right now to my calculator. You'll see that underneath my stats and in my lists, I've already entered my car data, and I've actually already entered data that we'll use for the other problems in this section. So I would ask you to pause the video and make sure that you have this data entered in so that you can follow along. If you have all of your data now entered in, I want to quickly go ahead and just note a couple quick things. First, I'll go ahead over here and I'm going to click on my my y equals, and I'm going to go ahead and create just a quick scatter plot of the data that I have here. I want to see what the car data looks like. So remember, that means I'm going to do my first option, list 1 and list 2, and I'm going to hit zoom number 9. Okay, so once I have this right here, I can see that here comes my line of best fit. You may or may not have that in your picture. It's not super relevant. But I can see all of my dots. And I can see here that in this sample data, there appears to be a downward trend. But notice, that doesn't tell me anything about what the population of all cars would look like. This is just 10 cars. Imagine that instead of only 10 dots in this picture, I needed like 100 million dots in the picture. Well, the picture could look very different by the end. I might get dots at like all these different points. Like everywhere where my mouse is pointing, I could imagine having a different dot. And that would create a picture that is extremely different, potentially, from the one that I'm starting with here. And so what we want to know is, I see that right now in my sample that my data goes down, but do I believe that once all the dots are put in the picture from the entire population, I would still have data that slopes down? Maybe, maybe not. So what we're going to see here then is that when I go to my hypotheses, my first hypothesis, H0, is going to actually claim that the population slope is going to be 0. That is, it's going to be a perfectly flat horizontal line, and there's no relationship between the variables. No relationship. Of course, I'm going to be squaring that off against my alternative hypothesis, which is that B1 is going to be less than 0. A negative relationship, the data will go down. So here I have a negative relationship. And I want to figure out if this, or which of these hypotheses is probably the best one to go with. So I'm going to go to my test statistic and start working through this. So I already have entered data into lists. And I can go ahead and start to take a look at all of my other checks. So my checks here start off fairly simple. My first check is that I have to have paired quantitative data. And of course I have that. Weight of a car, highway miles per gallon, they're both quantitative and they're being paired together. Not much to say here, I'll just check that off. For number 2 though, there's a little bit more to be done. Notice it says I need to have a scatter diagram and it needs to look roughly linear with no outliers. So I'm going to have to go ahead here and actually try to go ahead and sketch out a picture of what this scatter diagram looks like, so that way I have evidence of that I've actually done this check. So I'm going to go ahead and just kind of draw a quick picture of the scatter diagram that we showed on the previous screen. So I had a scatter diagram that looks something roughly like this. And so I can see that kind of general downward trend. So again, I can go and check this off. On check number 3, I have to do 2 things. I need to make sure I have a random sample, which clearly the problem states, but I also need to make sure that I have a residual plot, and that residual plot has no pattern to it. Okay, so I have my residual plot that I'm going to shape up here. Remember, this is the one that often has this horizontal line across the middle. Okay, and in order to go ahead and create this picture, I need to recall that I have to go ahead and run my test so the calculator will update and know that we're using this data for residuals. So when I go back to the calculator, I'm going to go to Tests, I'm going to go to my Linreg T-Test, and I'm going to make sure that I run this with list 1 and list 2. It doesn't matter what I select for my hypotheses or what I put in for this regression equation, if anything, for the moment. I just click calculate, and it doesn't even matter the numbers. I just want the calculator to make sure that those lists are the lists that we're using. So now when I go back to stat plot and I go here, I can create a residual plot. Remember, this means I'm going to leave L1 where it's located, and I'm going to change out my Y list for my resid list. Remember, to find this, I click on second and the stat button, pulls up all my lists, and somewhere in here you should see resid. If I enter that in and then hit zoom in the number 9, here's my residual plot. This is our picture of America that we kind of talked about in the last video. So if I was to go ahead and take a look at this here, sketch this out as kind of my evidence that I performed this check, I get something that looks like this. Let's see, so I had a dot about here, there, and there, and then I had another one about down here. Okay, so this seems to definitely be a scatter plot that looks like a big splattering of points. There doesn't seem to be any predictable pattern, so I'll go ahead and check that off. Okay, for check number 4, this is my last check, I need to make my final picture, which is that normal probability plot for residuals. If I go back to the calculator, I'm going to go back to my stat plot, and I'm going to make sure that I swap over to this very last option. And in here, I can go ahead and I can just type in my resids list. And then if I hit zoom and the number 9, everything's good to go. That's the picture I want to copy down, and it does look like it's roughly linear. So swapping back, I'm going to go ahead and just provide a rough sketch of what that picture looked like. Looks something like this. And like that. Roughly linear, no outliers. Check. So all of my checks are completed. That's the part of the test that takes the longest. But now I'm ready to get my test statistic. I'm ready to come down here and actually sketch out my t-distribution, because I want to figure out the values of B1, the value that I expected and the value that I got, and I want to see how they compare. So let's see. Really quickly, let's go ahead and actually run the test on the calculator again and see the values that we get. So I'm going to go to Stat and Tests, and then I'm going to go down to this Linreg T-Test. Over here, I'm going to make sure that this time I not only have list 1 and list 2 in, but that I select the correct value for this alternative hypothesis. You can kind of ignore this P looking symbol here in the and just focus on the big B. Okay, so we had something that was, just like this option that's already highlighted. B is less than 0. That was our H1. So when I go to calculate, I'll get a whole bunch of different values here. I have my t-score and my p-value. So I'm going to go ahead and sketch this out. All right, so my t-value was negative 4.0236. And it's important to note not just my p-value, but also what was the value of B1. That is, what was the slope of my line of best fit? Well, if I look in here, again, keep in mind that b is the number in front of x, and so it represents the slope. So this value, negative 0.0046, is my slope. That is the value that I got for my little slope, and it's going to be somewhere over here. And the reason that I know it's on this side is because I would believe, if H0 is true, that my slope for the population should be 0. And so I would believe that the slope for any sample is most likely to be 0. So therefore, I got something that's a little bit below average. And I want to test if what I got is weird to see by chance or not so weird. So this space right here represents my p-value. It's the probability of getting a B1 less than negative 0.0046. And the calculator gave me a value of 0.0019. Since my value of alpha on this question was given as 0.01, I can see that I have a rare slope based on my cutoff criteria here. So that means that I would reach the conclusion that I should reject H0. So I would state my conclusion as follows. I could say it is rare to get a sample slope of negative 0.0046 by chance if the population slope is 0. It's rare to see what we saw by chance if the population slope is 0. So therefore, we have enough evidence to conclude that the population slope is less than 0. That is, it is negative. So of course that means that we believe there is a negative relationship between the variables. That is, specifically the variables of highway miles per gallon and the weight of a car. What we've said here is that based on the evidence, while I can see that the sample data goes down, I also believe based on the evidence that all of the population data values will also tend downward. So this is how I would conduct a test, the final test that we'll talk about this